Group 16. Now let us see the elements of group 16, which are also called oxygen family. It consists of, let's first do the introduction. It consists of oxygen, sulfur, selenium, tellurium and polonium. Out of this, the oxygen, sulfur, selenium are non-metals. Tellurium and polonium are regarded as metalloids. Polonium is radioactive in nature. It's a highly poisonous element. So it's basically not studied in detail. So we are left with only the 4 elements. The occurrence, let us first discuss their occurrence. What we find is oxygen is mainly extracted from air. We know that by the liquefaction of air followed by its fractional distillation. So it's mainly obtained from there. Sulfur exists in the form of sulfur beds and also in combined state in the form of number of sulfate like Epsom salt is there and other sulfate salts, or in the form of sulfide ores like zinc sulfide, lead sulfide, copper sulfide, copper pyrites, etc. The selenium and tellurium, they also exist as selenides and tellurides along with the sulfur ores in the form of sulfide. Along with the sulfide ores, they are also present in the form of selenides and tellurides. And polonium is mainly obtained from the uranium and thorium series. So these are their general occurrence. What I need to tell you again in this cases is their next is their electronic configuration. They have a general configuration of NS2 NP4. So they are having valence electrons are 6 with them. Now let us discuss their atomic size and ionic size. The atomic size is smaller than group 15 elements, and both atomic and ionic sizes are smaller than group 15 elements, and it increases down the group because of the addition of the new shells. Then let us move to the next property, the ionization energy or enthalpy. Ionization enthalpy. If we compare the first ionization enthalpy of oxygen with that of nitrogen, what we find, nitrogen is having higher value. So what we write is their first ionization enthalpy is lesser than group 15 elements. Why it's lesser? Because group 15 elements are having stable NS2, NP3, half filled configuration. The ionization enthalpies decreases down the group because the atomic size increases. Now let us move to the next property of these group 15 elements. The next property of group 15 elements is their electron gain enthalpy. This is what the symbol is, or their electron affinity. Their electron affinity is higher than group 15 elements. Obvious, because sizes are smaller and the nuclear charge density is much higher, and it decreases down the group because atomic size increases. So what we find is the oxygen is the one which is having the highest electron gain enthalpy, we believe. But yes, there happens a exception in this. The electron affinity of oxygen when compared with sulfur, we find that it's the sulfur which is having higher electron affinity. The reason is because it's having bigger 3p orbitals or subshell, in which lesser inter-electronic repulsions takes place. Therefore, more tendency to accept electron. Whereas in case of this oxygen, they have smaller 2p orbitals, therefore more repulsions. That's why what we find sulfur to be having the higher values, higher affinity, and then it decreases then onwards down the group after sulfur. Let us discuss now the electron electronegativity. Remember, group 16 elements are more electronegative than group 15 elements. So they are more electronegative than group 15 elements, and it decreases down the group. Why it decreases? Because the atomic size is increasing and the ionization enthalpies are decreasing and the electron gain enthalpies are decreasing. Affinity is decreasing. So that's why what we find is they are becoming lesser and lesser electronegative. So oxygen is the second element after fluorine to be having the highest electron negativity. Now let us discuss their physical states. See, oxygen exists as a gas, as a discrete diatomic gas, because it has a tendency to form p-pi bond, so it exists as a discrete diatomic gas molecule. But since sulfur cannot form p-pi bond, it is bound to form bonds with two more sulfur atoms, and in this way it forms this kind of a structure. If you remember, it's called crown shaped structure or puckered structure, and this is how its 8 atoms combines with each other. So sulfur exists as S8 molecular units, so it becomes solid. Similar is the behavior shown by selenium and tellurium. So they all are solids, whereas the oxygen is gaseous substance because it has tendency to form p-pi bond, so it exists as a discrete diatomic gas molecule.